Okay, let's get some help on section 5.4. And this section deals with fractions and a few other little properties that you'll need to know about numbers. First of all, the main thing that we're going to be using is the number one. And I like to say that the number one is the most powerful number in mathematics. And the reason why is because you can multiply or divide any number by one and that number doesn't change. So I call it the master of disguise. So any number any fraction that has the numerator and the denominator, they're both the same, then that is equal to 1. So here I've given you some examples: 15 over 15, 2 over 2, negative 100 over negative 100, or a over a. So um, anyway, we will be using this property a lot in this section. Let's look at example number one, where you have to reduce a fraction. And so if you think about this fraction, 15 over 20, the first thing that you want to think about is common factors of 15 and 20. So we talked about factors in the last lesson, a couple lessons ago. And so if you were to look at those factors, you would find that 5 is the greatest common factor of 15 and 20. All right, so what we can do is we can rewrite 15 and 20 as 5 times another number. So this is what I did. 15 is 5 times 3, and 20 is 5 times 4. Um, the one thing to note is that this fraction right here and this fraction are equal to each other. They look different, but they're equal. It's kind of like if you were to say 4 quarters and $1. They look different, but they spend exactly the same. So we can rewrite this fraction. Well, notice that you have that 5 over 5. And remember, what is that? Secretly, that is 1. And so really, I can replace 5 over 5 with 1 because they're equal. And so then you can reduce this fraction. 1 times 3/4 is just 3/4. So 15 over 20 in reduced form would be 3/4. All right, let's look at a harder example on this. So I look at these numbers. Anytime I see that the numbers end in a 0, I know that they are divisible by 10. And so I'm going to go ahead and just break these numbers up in a couple of different steps. So I broke it up: 10 times 45, 10 times 100. Again, I have that 1, so I can take it out, and I have 45 over 100. This is not in reduced form because if you have, they still have common factors. So I know that both of these are divisible by 5 because that's a factor of both 45 and 100. So again, I'm going to reduce again. I'm going to take out that 1 and I get 9 over 20. Now, I think about factors of 9 and 20, and they do not have any factors in common, so that is going to be reduced form. Now, the easiest thing to do with fractions is to multiply and divide. Simply because, by definition, all you have to do when you multiply and divide fractions is multiply. Well, when you multiply fractions, you are multiplying numerators and multiplying denominators. So in this case, you would have 3 times 4, 5 times 7. You get 12 over 35. You need to always ask yourself if that is reduced or not, and there are no common factors between 12 and 35, so that would be your final answer. Now, to divide actually means to multiply by the reciprocal. So we need to think about this word reciprocal. And by definition, so let's look at an example of that. Well, we're going to take the reciprocal of 4/7. And the reciprocal of 4/7 just means that you are going to flip that fraction upside down. So instead of 4/7, it's now going to be 7/4. So going back up here to our problem, we are going to have 3/5, and instead of divide, we're going to multiply by the reciprocal of 4/7. So that means you're going to have 3/5 times 7/4. And again, multiplication, you just multiply numerators, multiply denominators, and you get 21/20. There are no common factors, and I am going to leave it in that form. Okay. Now, you're going to have some problems that have negative exponents. And so a negative exponent means that you are going to take the positive reciprocal. Let's look at an example. If you have 7 to the negative first power, we are going, the 7 is the base. And so we are going to take the reciprocal of the base, which is 1/7. So remember that this is the same thing as 7/1. And so I'm going to flip this and do 1/7. And when you do that, the exponent becomes positive. So it doesn't matter what the exponent is. It could be 7 to the negative 2. And when you flip it over, it would be 1/7 squared. So it just makes that to be a positive exponent. And 7 to the first power is just 7. So let's look at an example that you're going to have in your homework. You have this problem, 8 divided by 8 to the negative first power. The first thing I want to do is I want to get rid of this negative exponent. So we're going to apply this rule up here. So I'm going to take the reciprocal of 8/1, and that's going to be 8 divided by 1/8. Now remember, this is 8/1, and when you divide fractions, you multiply by the reciprocal, okay? So now I'm going to have to take and flip this upside down again in order to multiply by the reciprocal. So you're going to actually get 8 times 8/1, and that ends up being 8 times 8, which is 64. So what started out as an ugly problem ended up to be not so bad. You're just taking several reciprocals. And you will have some examples like that in your homework. Now, when we talk about adding and subtracting fractions, this is where things get harder because you have to add and subtract fractions with common like denominators. So, for example, if you've ever done cooking, you can't take and add, um, you know, unlike amounts of measurements. Like if you had a half of a cup plus a fourth of a cup, it's hard to add those together because they don't have the same denominator. Now, what you can do, you've got to make, when you're adding and subtracting fractions, you've got to make common denominators. So this is where adding and subtracting is the hardest part to deal with fractions, but our one secret disguise, that number 1 is going to come in handy here. So let's look at this example, and it turns out that you have problems like this. We have all these negative exponents, and the first thing you're going to do is get rid of those. So remember, we just talked about how you get rid of those by taking the reciprocal, and so then they become positive exponents. So all of these are going to be positive exponents down here once we take the reciprocals. Now, you have 1/2, 1/5, and 1/9, and there's no way for you to add all of those up unless they have common denominators. So what I need to do is I need to change all of these into a common denominator, but I've got to figure out what that common denominator is first. So what I'm going to do is I'm going to look for the least common multiple between 5, 2, and 9. I wrote this out in vertical format, and you'll see why in just a second. It just helps me to work this problem out by doing it in vertical format. And so I'm going to look at those denominators. The least common multiple is actually multiplying all 3 of those numbers together. And so I get 2, 5, and 9. I multiplied them all together, and I got 90. Now, so what happens is that I have got to change this 1/2 into the equivalent form of some number, numerator, over 90. Now, in order to do this, I'm going to multiply by a disguise of 1. So this right here is going to be my magic number 1, but what I need is whatever number in the denominator that I would multiply 2 by this number to get 90. Now, you can just say 90 divided by 2, and you're going to find out that it's 45. So I actually know that my magic number here, magic number 1, is 45 over 45. So now 2 times 45 is 90. 1 times 45 is 45. So it turns out that 1/2 is exactly the same as 45 over 90. They look different, but they spin the same, just like 4/4 and $1. Okay, now I'm going to do the same thing with 1/5. So I need to know what 1/5 is with a denominator of 90. So I'm going to say 90 divided by 5, and I will get 18. So 1 times 18 gives me 18. All right, then finally I have to do the same thing to the 9. 90 divided by 9, 10 over 10 is my magic number 1. 10 times 1 is 10. Now that I have everything in equivalent, um, all of these original fractions here, I have their equivalent forms. They all have the same denominator of 90. When they all have the same denominator, all you have to do is add the numerators. So I'm just going to take those three numerators, 45, 18, and 10. I'm going to add them together, and I'm going to get 73. Okay, so 73 over 90 is actually my final answer, and that is in simplified form. So let's look at another example of adding and subtracting fractions. Okay, here is another example from your homework where you actually have a mixed fraction. So a mixed fraction is one where you have a whole number and then you have a fraction. So the first thing we want to do is we want to get rid of these whole numbers, and you can't just magically make them go away. You have to do it correctly in mathematics. So these are called proper fractions. We are going to turn them into improper fractions. And so let's take the first one, 1 3/5. And what you're going to have to do is you're going to have to do a couple of steps. And I kind of like to think of it in this way. So I'm going to take 5 and I'm going to multiply it by 1. Now I'm going to deal with this negative in just a second. The answer is going to be negative. So just kind of ignore that negative for right now. But I'm going to say 5 times 1. And then I'm going to add the numerator. So I have 5 times 1 is 5. I'm going to add the numerator, and that is 8. And so that turns out to be 8 over 5. And then I'm just going to put the negative back in there. Okay. So, 1 3/5 is the same thing as 8/5. So negative 1 3/5 is the same thing as negative 8/5. All right, so I'm going to do the same thing with all three of these proper fractions. Okay, and this is called an improper fraction because the numerator is bigger than the denominator. So I'm going to do the same thing here. So I'm going to have 8/5. The second one turns out to be 41 over 8. That came from 8 times 5 plus 1. And then I'm going to have negative 71 over 10, which is 7 times 10 plus 1 would give me the 71. And I had to put the negative in there. Okay, now you need to look at the least common multiple of 8, 5, and 4. No, I'm sorry, 5, 8, and 10. So over here, I showed you that the least common multiple of 5, 8, and 10 turns out to be 40. So I did the same exact thing that I did in the last problem, where I had to find this magic number 1 to change all of these fractions over to equivalent fractions with the denominator of 40. So it turns out that I got ugly numerators, but it doesn't matter how ugly it is. they all work exactly the same. So now all you have to do is add all of those numbers together. So you're going to have negative 64 plus 205 plus a negative 284. And so if you have problems with that, grab a calculator and just do it, and that would be fine. This is going to be negative 143 over 40, and we are going to leave it in that form. Okay, so I know it was ugly, and you get an ugly answer, but the steps are exactly the same. We're going to look at one last example, and you've got a couple of problems like this that are just really, I call them really ugly fractions because the denominators are so large. But again, it's the same exact process, just with big numbers. So I'm not going to take a lot of time to try to figure out least common multiples of these. I'm going to show you how I would tackle this problem. And there are different ways of tackling every problem, but this is just the way that I do it. So I'm going to take this problem, and I tried to find the least common multiple, and that was just taking too long. So I just multiplied all three numbers together, okay? So I get this massive number of 4,665,600. Okay, now that is going to be my denominator. As super huge as that is, we're still using the same exact process. So I'm going to take my three numbers, I'm going to write them in vertical form, and then I'm going to change all of these denominators to this super huge denominator, 4,665,600. Okay, so 4,665,600. So it turns out if you take this big 4,665,600, divide it by 144, you get 32,400. I multiplied that by 13 and I got this number 421,200. I did the same thing with 7 over 300, and you end up with a numerator of 108,864. Did the same thing with the third one, you get a numerator of 820,800. Again, grab your calculator, just take this number, the big denominator, divide it by this denominator, and that gives you your magic number 1. Now, as always, you will then just take and add your numerators together, and you're going to get this super huge number. Now, here is where this number is different. I know that this number, this fraction can be reduced because the both of these are even numbers. So I know they're at least divisible by 2. So now I have to go through and reduce this. So what I did is I grabbed my calculator and I saw that they were both divisible by 2. Then I found that they were divisible by 4. They were both, and I just kept kind of going through, and I ended up stopping at 16. Okay, so I knew that both of them were divisible by 16. So I went ahead and reduced this by 16, and I end up getting this fraction. So now I have to kind of look and I have to see, is there anything common between these two numbers? Well, I looked at this 9 and I just decided, well, let's see if it's divisible by 9 and if the denominator is divisible by 9. And it turns out that they were. So I went ahead and reduced again, divisible by 9. All right, so now I'm down. It's getting smaller, which is good, but I'm still trying to figure out if this is in complete reduced form or not. So it turns out this ends in a 1, and anytime it ends in a 1, I try to divide by 3, and the reason why is because I know 3 times 7 is 21. So I know that it's possible to have a 1 as your last digit, and if it's divisible by 3. And so it turns out top and bottom are both divisible by 3. So again, I reduced by 3. Finally, I look at these two numbers, okay? And I did some calculations on those, and I could not find anything else that these two numbers were divisible by in common. So it turns out that that is your final answer. So even as ugly as that is, it turned out to be not so bad because I only had to go through three reductions here. And so then I got my final answer. So hopefully that will help you through the homework problems in this section. They will take a little patience, and there are multiple ways of looking at each problem. So, but maybe this will help you get through this a little bit easier.